Hey everybody, we're doing IIT JEE 2023 Physics Paper 1, and we are on section 3, and it has 6 questions, and done the 2 questions in previous 2 videos, and this one is question number 10, which is the third question in section 3. Okay, so this one is a little silly problem. Does a physics experiment, and in the physics experiment you have some uncertainties, and how to propagate those uncertainties. Normally in the lab you're going to propagate through quadrature, but like a square root and squares inside, like independent. But here those independent sources of uncertainty, you're going to propagate them through absolute values. Okay, so that's the let's look at the problem. Okay, so this is the problem, and so you know, so if you if you have done this experiment to find the focal length of this, you kind of put an object here far away enough to be, it's like focal length is somewhere here, and you put away as like a lamp or something, and you move your screen, and say you find the bright image over here. Okay, so when you measure p, you don't get a p, you have p plus delta p, and when you measure q, you don't q, you get a plus minus delta q. So how do you get f? So you have to do calculation using 1 over f equals 1 over p plus 1 over q. So what this is okay, so f is going to be pq over p plus q. So you can see f is a function of p and q, so you can think of this as f is a function of p and q. So it's like a multivariate. So any change in p and q can be related with like this: df equals to, take a partial derivative with the p dp, so this is correspond to that, plus df dq, right? And we want percentage. If the problem is to find the error n%, the percentage will be basically divide by f. To get the percentage, you have divide by f and divide by f. So this can be plus or minus, and this can be plus or minus, and usually you will do, suppose this is some dx and this is some dy, then usually you will have a dx square plus dy square kind of thing. Okay, when you combine the errors. But in this syllabus, this is not we're going to do. We're going to do dx plus dy. It's kind of like this, not square root, dx plus dy, just dx plus dy. Okay, so that's another way of doing it, but that's the way they want you to do it. Okay, in that way, this whole problem is just silly. So let me just pause the video and work out the little calculus algebra here, then show you what the numbers and how the numbers will work out. Okay, so I went ahead and worked out first I did this, take a derivative, and then I did this. So if you divide this, because I can combine these guys and combine this separately, right? So this f goes with this and f goes with this. So it will just simplify further. It just becomes this, and I don't need to do the q, because the q will be just, this will by the symmetry is just 1 over q. So you don't have 2 different derivative, just one is enough. It's like from here I can right away say 1 over f df over dq will be 1 over q, 1 over p plus q, just from the symmetry of this formula. Okay, now I put it there and I just plug in numbers. Be careful when you're plugging these numbers, and even if you work out all that, you can still mess up here. When in the test situation is tense and got to be relaxed, okay, and do this and you get a very nice answer, 1%. So this was, to me, it was a, I would call it a stupid problem. It's not, it doesn't really take a lot of thinking. It's just doing a derivative and make sure that you don't make some silly error. Okay, so I'm going to move to in the next video. I am going to do the next problem. Where is the next? Here. So the next problem is going to be, next problem is this 11, and that's going to be an ideal gas thermodynamics problem, looks like. Okay, all right, see you in the next video. Bye.